Welcome to a deep dive.
Yep.
This one is going to be all about the pretty fascinating world of neuromorphic computing.
It really is a fascinating world.
It is. Get ready, because this is definitely a field that's, I think, about to just revolutionize how we even think about computers
Right.
and maybe even intelligence itself.
Yeah, what's so intriguing about it is that it's not just about making computers faster.
Right.
It's about fundamentally changing how they operate. It takes inspiration from the most complex and efficient information processor we know, the human brain.
Okay, so let's unpack this a little. For those who haven't maybe encountered this term before, can you explain what neuromorphic computing actually is?
Yeah, so at its core, neuromorphic computing is about building computer systems that mimic the structure and function of the human brain.
Okay.
So instead of relying on traditional transistors and digital logic,
Right.
these systems use artificial neurons and synapses that communicate using pulses of electrical activity, just like real neurons do.
So instead of lines of code and algorithms, we're talking about networks of interconnected artificial neurons that can learn and adapt in real time.
That's exactly right. And one of the key advantages of this approach is that it allows for massive parallelism, meaning that these systems can process huge amounts of information simultaneously, just like the brain.
Yeah. This sounds like a complete departure from how traditional computers work. What even prompted this shift?
So one of the driving forces behind neuromorphic computing is just the limitations of traditional computing architectures, particularly what's known as the von Neumann bottleneck.
Oh, now I've heard that term before, but can you remind me what it refers to?
Yeah, so in traditional computers, there's a clear separation between the processing unit, that's the CPU,
Right.
and the memory unit. And data has to constantly shuttle back and forth between these two units, and this creates a bottleneck that limits speed and consumes a lot of energy.
So it's like having a brilliant chef stuck in a tiny kitchen with only one oven. They can only cook one dish at a time, no matter how talented they are.
That's a great analogy.
I try.
So now imagine that chef having a whole array of ovens and cooking stations all within arm's reach.
Yeah.
That's what the brain does so efficiently,
Right.
and what neuromorphic computing is trying to replicate.
Okay, so by mimicking the brain's integrated structure where the processing and memory happen in the same place, we can overcome this bottleneck.
Exactly.
Right.
And that opens up incredible possibilities for speed, energy efficiency, and the ability to just handle complex, unstructured data that kind of characterizes the real world.
Yeah, speaking of efficiency, one of the most exciting aspects of neuromorphic computing is its potential to drastically reduce energy consumption, right?
Absolutely. Traditional computers are incredibly power hungry, especially when they're dealing with things like artificial intelligence.
Right.
But neuromorphic systems are designed to operate on an event-driven basis, meaning they only consume energy when there's actual information to process.
Okay, so it's like the difference between leaving a light bulb on all the time
Yes,
versus having a motion sensor that only turns the light on when someone enters the room.
exactly. That's a great way to put it. This event-driven approach makes neuromorphic systems so energy efficient, potentially using a fraction of the power required by traditional computers.
Yeah, and that's crucial, especially as we kind of move towards a world of just ubiquitous computing with sensors and smart devices embedded in everything,
Hey.
from our homes and cities to our bodies.
Exactly. Imagine smartphones that last for weeks on a single charge. Imagine data centers that can operate with just a fraction of their current energy footprint. Imagine deploying vast networks of sensors without worrying about constantly replacing batteries.
And it's not just about saving energy. Neuromorphic computing also promises to just revolutionize how computers even learn and adapt. Can you tell us a bit more about that?
So one of the key characteristics of the human brain is its plasticity,
Right.
its ability to rewire itself based on experience. And that's what makes us so adaptable and able to learn new things throughout our lives. And neuromorphic systems are designed to capture the same ability for adaptation.
So they're not just programmed with a fixed set of instructions, but they can actually learn from their experiences and modify their behavior over time.
Precisely. And this learning can happen in real time as the system is interacting with its environment. This makes it ideal for tasks like recognizing patterns, making predictions, and navigating just complex, dynamic situations.
It sounds like we're talking about a whole new level of artificial intelligence.
Yes.
One that's much closer to how humans learn and think.
Mm-hmm.
But how do these neuromorphic systems actually learn?
It all comes down to the way that artificial synapses are designed. Remember those connections between neurons?
Yes.
So in neuromorphic systems, these synapses can actually change their strength based on the patterns of electrical activity that are flowing through them.
So the more a particular pathway is activated, the stronger that connection between those neurons becomes.
Exactly. This process is known as synaptic plasticity. And it's like one of the fundamental mechanisms underlying learning and memory in the brain.
And to make these artificial synapses even more brain-like, researchers are using a special type of electronic component called memristors.
That's right. Memristors are a revolutionary technology because they can remember their past electrical history.
Okay.
So essentially, they can change their resistance based on how much current has flowed through them before.
So they're like tiny electrical switches that can gradually adjust their on or off state based on experience.
Precisely. And this makes them perfect for mimicking the adaptable connections between neurons in the brain.
It's fascinating to see how advances in material science are converging with our understanding of the brain to just create these incredible new computing technologies.
It really is. It's a very interdisciplinary effort, drawing on insights from neuroscience, computer science, physics, engineering.
Yeah.
And it's still a relatively young field,
Yeah.
which means that there's just a lot of room for innovation and discovery.
Yeah. I'm already starting to see how this technology could have a profound impact on so many aspects of our lives.
Yeah.
But let's delve into some specific examples. What are some of the most exciting potential applications of neuromorphic computing?
Well, one area where neuromorphic computing is poised to make a huge impact is robotics. Imagine robots that can learn and adapt in real time, navigating complex and unpredictable environments without any constant human intervention.
Yeah, no more pre-programmed movements
Right.
and rigid responses.
Exactly.
These robots could truly learn from experience just like we do. Where else could this be applied?
They could adapt to new situations and solve problems creatively and even interact with humans in a more natural and intuitive way.
Yeah.
Imagine all the possibilities in industries like manufacturing, search and rescue, or even space exploration.
It's incredible to think we could have robots working alongside humans, not just as mindless machines,
Right.
but as collaborative partners that can learn and grow with us. And speaking of learning and growth, what about the impact on artificial intelligence?
Yes, AI. Neuromorphic computing is a game changer in AI because it tackles one of the biggest challenges in AI development, creating systems that can really learn and adapt like the human brain.
I imagine that this shift from traditional AI algorithms to brain-inspired systems will bring about some pretty significant advancements. Can you give us a glimpse into what we might see?
Well, for one, we could see a new generation of AI assistants
Yeah.
that are far more personalized and intuitive. Imagine having a digital assistant that understands not just your commands,
Right.
but your preferences, your habits, even your emotions.
Wow.
It could anticipate your needs and help you in ways that are truly tailored to you.
That would certainly revolutionize the way we interact with technology. It would be like having a truly intelligent companion that's always learning and growing with you. Are there any other areas where this kind of adaptable intelligence could be impactful?
Absolutely. Think about fields like healthcare, where AI is already being used for things like diagnosing diseases and developing new treatments. But with neuromorphic computing, we could take personalized medicine to a whole new level.
You mean AI that can analyze an individual's unique genetic makeup, lifestyle, and environmental factors to create truly customized treatment plans?
Exactly. And it could even monitor a patient's health in real time, detecting subtle changes and alerting doctors to potential problems before they even become noticeable.
Wow, it's exciting to think that we might one day have AI-powered medical devices that are as adaptable and responsive as our own immune systems, constantly working to keep us healthy. It sounds like this technology could even help us unlock the secrets of the brain itself.
You're absolutely right. By
Right.
building systems that mimic the brain, we're also gaining valuable insights into how our own minds work.
Yeah.
It's a two-way street.
Right.
We're using the brain to inspire new computing technologies, and those technologies are helping us unravel the mysteries of the brain.
It's a remarkable synergy of science and technology.
It is.
What are some of the key areas of brain research that could benefit from neuromorphic computing?
Well, one area is understanding how learning and memory work at the neural level. By creating these artificial neural networks that can learn and adapt, we can test different theories about how these processes work in the brain.
So we could actually simulate different learning scenarios and observe how the artificial neurons change and adapt.
Precisely. And this could lead to new insights into how memories are formed, how skills are acquired, and even how certain neurological disorders disrupt these processes.
It's amazing to think that we could one day have like virtual brains that can help us understand the complexities of the real thing.
Yeah.
What about the field of brain-computer interfaces? I imagine neuromorphic computing could have a big impact there as well.
Oh, absolutely. Brain-computer interfaces, or BCIs,
Hmm.
allow us to communicate directly with the brain using electrical signals to control devices or even restore lost function.
So we're talking about things like prosthetic limbs that can be controlled with thought, or devices that can help people with paralysis regain movement.
Exactly. And neuromorphic computing could play like a key role in making these BCIs more sophisticated, more responsive, and more intuitive to use.
Right.
Imagine a prosthetic limb that can learn and adapt to the user's individual movements, or a BCI that can decode complex thoughts and intentions.
It sounds like we're on the cusp of a future where the line between mind and machine becomes increasingly blurred.
It does.
But as with any powerful technology, there are also ethical considerations to keep in mind.
Of course. You know, it's crucial that we develop and use these technologies in a responsible and ethical way. We need to make sure that they're used to benefit humanity and not to harm or exploit individuals or groups.
It's a conversation that we need to have as a society as we venture into this uncharted territory of brain-inspired computing.
Right.
But before we get too deep into like the ethical
Yeah.
implications, let's bring it back to the practical side of things. Who are some of the key players driving this field forward?
Well, one of the pioneers in neuromorphic computing is IBM with their True North chip. It's a digital neuromorphic processor
Okay.
designed to mimic the structure and function of the brain. They've been doing some groundbreaking work in this area for years.
And I've heard that Intel is also making significant strides with their Loihi chip, which is specifically designed for on-chip learning and adaptation. It's fascinating to see these tech giants investing in this emerging field.
It really speaks to the potential they see in neuromorphic computing. And it's not just the big players either. There are a number of smaller companies and startups that are making really significant contributions, developing new neuromorphic hardware, software, and applications.
It's a truly collaborative effort, with researchers and engineers from around the world working together to push the boundaries of what's possible. What about academic institutions? What role are they playing in advancing this field?
Universities and research labs are playing a crucial role in both fundamental research and the development of new technologies. For example, the Human Brain Project, a massive research initiative funded by the European Union,
Okay.
is working to create detailed simulations of the human brain, and they're using neuromorphic computing as a key tool in their research.
It sounds like there's a lot of momentum building behind this field, but I'm
Yeah.
curious, what are some of the biggest challenges that researchers are still facing?
Well, one of the biggest challenges is developing software that can effectively harness the power of neuromorphic hardware. These systems operate so differently from traditional computers.
Right.
So we need new programming languages, tools, and algorithms that are specifically designed for this type of architecture.
It's like trying to write a symphony for an instrument that's never existed before.
That's a great analogy. It requires a whole new way of thinking about programming.
Yeah.
And then there's the challenge of scaling up these systems. Right now, most neuromorphic computers are relatively small, with a few million neurons at most, but the human brain has billions of neurons, so there's a long way to go in terms of scaling up to achieve brain-like complexity.
Yeah, it sounds like we're still in the early stages of this technological revolution.
Mm.
But with the progress being made and the incredible potential of this field, I'm eager to see what the future holds for neuromorphic computing.
I share your enthusiasm. I believe that neuromorphic computing has the potential to revolutionize not just the world of technology,
Right.
but also our understanding of ourselves and the universe around us.
And as we learn more about the brain and how to replicate its remarkable capabilities, who knows what incredible discoveries and innovations await us.
Yeah, and it's not just about existing fields. I
Yeah.
imagine that neuromorphic computing will also lead to the creation of just like entirely new industries and job roles that we can't even imagine yet.
Absolutely. Just as like the invention of the computer led to the rise of software development, data science, and countless other fields, neuromorphic computing will create a demand for new skills and expertise.
We'll need people who can design, build, program, and maintain these really complex systems.
Yeah.
We'll need experts who can like understand and interpret the data they generate. And we'll need, ethicists, policymakers, and social scientists to help us navigate the societal implications of this technology.
It's exciting to think about the possibilities for like education and training in this emerging field.
Yeah.
Imagine universities offering specialized degrees in neuromorphic engineering
Right.
or online courses that teach people how to program these systems.
It's already starting to happen.
It is.
Universities around the world are beginning to offer courses and research opportunities in neuromorphic computing.
Wow.
And there are a growing number of online resources and communities dedicated to this field.
It's clear that neuromorphic computing is more than just a technological advancement.
Yeah.
It's a paradigm shift that will have profound implications for how we live, work, and interact with the world around us.
It's a journey into the unknown, but it's a journey that's filled with promise and possibility. And as we go deeper into this brain-inspired world of computing, who knows what incredible discoveries and innovations await us?
It's a future that I, for one, am incredibly excited to be a part of.
Me too.
So to all our listeners out there, I encourage you to just dive deeper into this fascinating field.
Yes.
Learn all you can about neuromorphic computing, explore the resources available, and who knows, maybe you'll be the one to make the next groundbreaking discovery.
And as you go on this journey of exploration, remember to keep in mind the broader implications of this technology.
Yeah.
Think about how it can be used to benefit humanity, to solve pressing problems, and to create just a better future for all.
Right.
The future of neuromorphic computing is in our hands,
Yeah.
and it's up to us to shape it wisely.
Wise words to end on.
Thank you.
Thank you for joining us on this deep dive into the world of neuromorphic computing.
It was a pleasure being here.
Until next time, keep exploring, keep learning, and keep imagining the possibilities.